Hello, everyone. Welcome to the Careers in STEM series. We are FRC Team 226 Hammerheads from Troy, Michigan, consisting of over 100 plus high school students from Troy and Athens High School combined. We compete in the first robotics competition, and we have been competing since 1999. This is a bi-weekly show occurring on the first and third Thursdays of every month. For this series, we'll have a short 30-minute interview period and then a 15-minute Q&A period for audience questions at the end. My name is Shaun Dantas, and I'm a junior at Athens High School.
My name is Sonnet, and I am a sophomore at Troy High School.
And today we have Ian Hartwig with us. Ian graduated from Troy High, and he was a former, I believe, programming lead of the robotics team. He went to Carnegie Mellon and majored in computer and electrical engineering, and he currently works at Zoox with a real focus on hardware and autonomous cars. So before we wanted to start, I would like to thank our sponsors. We really appreciate their effort and their contribution to our team, and we wouldn't be here without them. So before we start with the interview, please remember to put all your answers or your questions in the chat so that we can answer them at the end. And we're also going to read through a couple, and we might ask them during the interview. So Ian, let's start with high school. What sort of activities did you do at Troy High?
Yeah, definitely. Uh, some time ago now, but of course, one of the big activities I was involved in was FRC 226. It's not the only one, though. I was also pretty involved in like the Science Olympiad team and the like the environmental activists, which I don't actually know if that's still going, but kind of the group that goes around and promotes some recycling and environmental activism in the school.
With your experience on the team, did you have any really memorable moments? What was your general experience like?
Definitely. So, I mean, there's so many memorable moments. So actually, it's a little bit challenging to pick one. I think, hopefully, not too cliche. I think one of the big moments is actually the first year that I went to the Atlanta World Championships, and it wasn't actually the very first year that I was involved with the team, and the team went. I actually didn't go on the trip, but that second time, I definitely took the opportunity, and it's just the almost just that first moment when you're kind of walking up to the stadium, because at the time it was at the Georgia Dome in Atlanta, and kind of walking around to see the football stadium filled with all of the robotics things is just super powerful. Maybe it's just because we like to measure things in football fields in America, but it's really a sight.
It's quite a contrast from like looking at sports and then you just see a bunch of engineering kids there. It's a really interesting. So what was like your path through the robotics team? How'd you go from freshman to senior?
Yeah, definitely. So I actually started out kind of in the web and media section. So the first real in-depth part of the team I was working on was the website. So I think 226 has pretty great branding today. I think it was also strong at the time. Seems to have worked out pretty well for us. And it's all kind of that connected story. And then from there, especially the last year and a half that I was in high school on the team, I was working with the kind of more the engineering and the robots side. I think eventually I was helping as build lead, which it's kind of like it's one of the leadership positions that, especially at the time, was critical to the team to organize like the design and the manufacturing process, because we were working at the GM Tech Center, and we had really limited actually scheduled time and a limited number of students that we could bring in based on the GM graciously hosting us in the space. But we certainly, it was a situation where we certainly couldn't have like 100 students in there today, which so we would have to manage those trade-offs.
Since you had a lot of different experiences on a lot of different parts of the robotics team, for someone who's just getting into FRC or robotics in general, how do you think they should make the most of their high school robotics experience?
Definitely. I think, I mean, the overall part of probably the overall part of FIRST is do parts that you think are fun, and that you enjoy, and don't be afraid to pick up new tasks, because really it's all about introducing students to so many skills that you might not have an outlet for until you really get kind of into industry. Uh, uh, so I would say really go after kind of new and exciting things.
Would you say that FIRST or robotics was like your biggest influential moment in moving to engineering? Was that like your like inspiration for doing engineering college?
I think probably I already knew that I would want to do something engineering related. I think that's perhaps something that runs more in my family. So as it happens, actually, my mom is also a computer engineer. Um, uh, not sure how close that connection actually lined up. Probably some influence. But I would say that like FRC and robotics is what really both cemented it and explained how these different skills were really useful, and how wide the application was. So as it happens, like even though I might have that same degree, like my day-to-day work now is very different, for instance, than what my mom has always worked on.
That's really cool. So since you did have a bit of engineering experience in high school with robotics and everything, when you switched over and you transitioned to college, how did that play into your major, or the college that you ended up attending?
Yeah, it's actually there's a couple of facets where that influences it. I think one of them is so I was at Carnegie. I went to Carnegie Mellon for electrical computer engineering. Uh, One of the really strong features, I think, of CMU is that it has all these pretty in-depth student organizations. In a lot of ways, it's somewhat similar to uh, how encompassing some of the FRC teams are. So, I went to visit. Uh, I could see that happening. I could see those, like the mix of that social and technical environment together, and that is one of the big influences for me to have gone there. I mean, of course, they have a very strong robotics program in history as well. I think I would say that was kind of like a maybe a prerequisite, because realistically, especially coming from Michigan, you have many really good options for going to like a technical engineering school.
So obviously, I think out of everybody we've interviewed so far, you're the one who's really like honed in on robotics. You've continued with robotics for like the longest, I'd say. You because you obviously you work with autonomous now, but that's like a big part of that is working with like developing robotic stuff that you do like that we do now on the robotics team. And I think um, what sort of benefits or how did the robotics team help you get into that into your school of choice and into the workplace now?
Definitely, uh, it's it's actually it's a really interesting question, because I think if you asked me when I was finishing school, so like maybe about 5 years ago, I would not have actually expected to work in robotics now. I actually didn't start my career in that when I came out to the SF Bay Area, for instance. And but it really is the influence of kind of interacting with a lot of people that are in kind of that first bubble, and kind of the stuff that I did in school. So I originally came out to the Bay Area, and I was working in kind of computer systems and servers, enterprise hardware development. But there is that kind of excitement that comes with kind of the moving vehicles, with those systems that kind of do take some action on their own, like a lot of those robotic systems. And I think that connection was really only possible because of people that a couple folks that I went to school with that actually came into a few the last company that I was at before Zoox. I landed there because of a contact from school who was also working there, and that's really how I broke into the autonomous vehicle space.
We sort of glazed over it in the past few questions, but if we hone in on it a little bit more, what really is your major, or what really is computer engineering or electrical engineering?
Yeah, it's a good question because it's really quite a broad field. I mean, you even have to have "and" in the title, so it is a little bit dependent on school. So at Carnegie Mellon, it's there's roughly 4 areas that are all included in the same degree. So there's not like anything on your diploma that will say, you specialize in this. But typically, students will pick up 1 or 2 special areas in that. So, for instance, the CMU breakdown is it's like analog circuits, digital design, or like Verilog FPGA chip kind of stuff. Actually, I guess one of them is signals and systems, which is more of like that's actually maybe the most traditionally closest to robotics. That leads into things like control systems, and like maybe you might see it as like PID in the practical first system. That's kind of, it's like all the math behind that. And then the 4th section there is embedded in systems programming. So typically like maybe microcontrollers, C assembly, up to even like operating systems, web systems, applications.
So I'm sure a lot of our viewers are wondering what's like the biggest difference between computer science and computer engineering, or maybe computer engineering and electrical engineering, like your major.
For sure. Some of it is very school based. So like, for instance, I know that like even though CMU has that split where it's like EE plus CE, and then there's kind of CS is actually like a separate department. Some of that's historical at CMU, whereas other places, like I know there's a lot of schools that have EECS, where it's kind of all lumped together in one, because it really is kind of like a spectrum of skills that all stack up onto each other. I kind of like the historical way that the CMU one came together. It's really that in that frame, it's that CS essentially came from the maths and humanities departments, and the computer engineering side was a growth out of the electrical engineering department. So that's why they're still together today. Maybe the more practical way to look at it is it's kind of like asking, we have this problem, and it's like, how can we solve this problem more effective using a computer, versus you have this problem and you say, how can you build a computer that's more effective at this problem? So a lot of times you do have folks from, they can start to look very similar, and you have folks from both working on the same problems.
That's really interesting. So, speaking of problems, I guess, what type of issues or projects are you working on now that you maybe started gaining exposure to in college and now in your professional career?
Yeah, I think probably the common thread around the different jobs that I've worked in my career is really about, they all kind of roughly fall under system integration. So it's kind of like, we have maybe some new technology or new chips, and we have a task that we want to perform with them, and it's kind of bringing those two together. A lot of times like for me, that's involved like either PCB design, integrating components that way, or it's buying like maybe some other companies make modules that are already have all the pieces in them, and we need to develop some software that specifically makes that happen. So that's roughly where it is. My current job is very close to the. We have a lot of new hardware that we've developed or have purchased, and bringing it all together to play nicely, to perform kind of one uniform task as a system. So all the data moves through the system in an efficient way. We're able to tell if there's any, if anything is breaking in the system, those diagnostics basically go to the right places. A lot of tasks related to that.
So, wrapping up with the college stuff, what sort of organizations or internships did you do in college, and how did they help you transition into the workforce?
Yeah, CMU also has actually a really strong system for putting internships together too, or maybe I should say it's. Well, they definitely. I'll definitely touch on some of the systems for that. They also, it's also a very popular thing to do as students. So I think practically everybody I knew there was working on something over the summer. It might have taken the form of internship programs at large companies. It might have taken the form of research with a professor. Definitely some other or self-directed research or something like that. So most of the way that they line up some of that is usually there's a couple big career fairs. I think actually most of my internship opportunities came out of those career fairs. So or some sort of in-person interaction, as well as through the organizations. So probably the ones that are not directly through that came from maybe somebody that I was kind of got to work with, knew, they graduated, they go to the company. So that's a really powerful mechanism as well. Yeah, just to briefly touch on a few of them, there's a robotics company that's actually in Pittsburgh, where I was we're actually kind of doing a lot of software testing via actually driving the robots around and recording results. I was really actually quite lucky to get one of the Google internships, and also which was largely kind of system software related, and then Apple, where I was doing hardware design for some products that you probably could still go buy at the Apple Store, which is pretty sweet. Yeah, and then the final one of those is what actually turned into I also went back there to work full time.
I know at CMU you were actually able to be a teaching assistant for quite a few courses. So could you tell us a little bit more about your experience doing that?
Oh, for sure. Yeah, depending on schools, they have kind of different they have different policies around having teaching assistants in courses. Even within CMU, for instance, it's a little bit different depending on department. And one of the really strong features, I think, of the CS and ECE departments there is actually having these a fairly large staff of undergraduate teaching assistants, which is sweet because maybe I was the one on the other side of the lectern, learning that content only a semester or two ahead of time. So it was very kind of very close to being able to turn that information around. For me, I think I really liked it because it was an opportunity to, I especially at the time, I felt like going to do more projects, do more courses, to work. I was really able to bring some of that information back and help the next generation of students. And it was like a super fast cycle. A lot of the undergrad TA roles, for instance, there would even make slides for recitations, which is a small, a smaller subgroup of the lecture group. Yeah, it was definitely a cool experience.
So, looking at your job now at Zoox, what does your working day entail?
For sure. Yeah, I probably should mention too that I'm currently working with Amazon Zoox, and what I'm talking about here is kind of like my personal experience as an engineer there. So not necessarily as like a total company spokesperson. Probably the current role that I'm in, which is hardware systems engineer, is maybe a three-way split between different roles or different responsibilities. So probably like 1/3 developing kind of new tools and procedures for connecting maybe new hardware or bettering how we like analyze existing hardware. Like, let's say we want to know if some feature on a GPU is working correctly or something. We might kind of write some exploratory tests around that. And then a second third is probably supporting the existing procedures that we already have. So we recently were talking about all these kind of these new types of vehicles that we've been putting together. So basically, as we put those together in the factory, my team is one of a few that's if there's something that kind of changed unexpectedly, or we there's something that's stopping the build at the moment, we'll usually be on in the loop, sometimes on call for that as well. And the third part of it is probably planning, which is actually really exciting for this role particularly, is kind of planning future projects that can help us improve the process. So a lot of discussion with other technical teams, maybe with our project management organization, et cetera.
Since there's a lot of new technology and excitement going into your day-to-day work life, what are you ultimately most excited about in the industry that you do work in?
Definitely. I think I really think that one of the most exciting parts of the autonomous vehicle space at the moment is just that it's really happening. It's here today, and I think you can kind of see that in some of the media publications about it, where I think that 5 years ago there might have been a lot of conversation about like if it was possible, and when we look at the media now, I mean, there's a difference in maybe some level of excitement, but I think if you chat with folks that are looking at it from they're like very involved with it, it's a question of when and how and not if. So that encompasses like a lot of different pieces. It's like it requires, we're kind of like at the I'm kind of working again at that integration level, but it required many years of kind of computer science research behind the algorithms, which are things that we wouldn't have used 20 years ago. It requires a lot of work down to like the chip and even the kind of regulation and policy level, because right now, even under our current roadway regulations, we wouldn't. There's some pieces of it that are still kind of being adjusted, but the really exciting part about it is that it's literally happening now.
So you've moved around a lot. How did you go about with like job interviews and negotiations, that sort of stuff?
Yeah, I have. I think depending on exactly kind of which fields you're working in, that might change a little bit. So it is somewhat. It's not too out of the ordinary around, for example, the Bay Area, to kind of move jobs every 2 years or so. Maybe, and it's really, especially a lot of the companies that I've been involved with are kind of, they're maybe pre-revenue companies or startups, and they're the specific goals at the time and the feel of the company can definitely change over time, which But if a place is really fitting your need, then a lot of times the best thing is to stay there. As far as maybe interview tips, probably the biggest one is be yourself. The best interviews are always kind of a really two-way conversation where it's about kind of the person to person, because even though there is a lot of technical skill in engineering, just as much about it is the teammates that you're working with and how well everybody's on the same page. Because all of these most exciting projects are going to be way bigger than any one person is building in a garage, for instance. As far as kind of the numbers part of kind of interviewing different places, I would, especially when, like, the Bay Area, for instance, market has both kind of startup-like companies and kind of public listed or for-profit companies, and those when you're looking at kind of like when you're looking at offers from those different places, the numbers might look very similar, but they have a lot of different features that are not just those top line numbers. So it's really important to understand kind of what's built into there. And it could be like as much as like 25 to 50%, even if the top line number looks the same.
Talking about a lot of the smaller companies that are available in the Bay Area and some of the bigger ones, since you had past internships at Apple and Google, what were those working experiences like, and why did you ultimately choose to not work at one of those like huge companies and work for a slightly smaller one?
Yeah, I mean, really, those were invaluable experiences, and if it weren't for the combination of each one of those experiences, I definitely would not be in the spot that I'm in, or be effective, maybe not quite as effective like in my current role. They were a little bit, those were kind of like interestingly different, actually. So I would say that Google was, I really enjoyed it because it was kind of it was learning how to build software in just a huge organization. I mean, they have so many different product focuses, and really just so many people that are all basically working together on the same code base with the same infrastructure. It's really, really impressive, and it's far different than when you're working on maybe a programming project for your college, for like one college class. The Apple side was really cool because it was really the first time I got to dive into in-industry hardware design. I think, and that was very cool because it involved shipping some, being involved in some shipping products as well, which is something that I really enjoyed. I think those experiences are definitely did influence me kind of working in maybe mid-sized companies is I think where I've kind of landed. To me, they've offered a really good mix of there's enough resources there, especially kind of in the hardware space. It's often kind of capital intensive, so you need enough. You need to have enough money in the back pocket in order to effectively, buy all these resources that you need. And at the same time, they're kind of small enough that the teams can move really quickly. It's very person to person. It's how much can happen is really closely attached to like the skills of each individual person you work with, I think.
So tying all these things together, what sort of advice do you have for high school students who want to follow your kind of path?
Yeah, probably the biggest piece of advice would be get involved in organizations that can basically magnify what you could do on your own. I think if you're already involved with something like FRC in high school, hopefully that's already something that's happening. I would say that when you get to, or I mean, it's probably likely that you'll move on from there into maybe a college environment. It's definitely not a time to kind of stop some of that involvement. It's probably even a better time to get involved. And it doesn't always have to be, something that's like an engineering or technical team. There's so many super cool organizations at the college level. Like one of the ones that I was involved with that's very not really engineering related is there's a thing called the activities board at Carnegie Mellon. And it's basically most colleges have something that's like this, where it's like the group that books like concerts and events and stuff. And it's just like, it's a great time to be involved and try out new skills when they have like kind of that huge impact. And then you can kind of just like keep chasing those kinds of activities all throughout.
Yeah, that's really interesting. We have a couple of questions from the audience.
Sure.
So someone wants to know, what language do you usually code the system in?
So probably not the answer that they were expecting, but through my career, actually, the vast majority of any software that I have written as part of work has actually been in Python. Essentially, I kind of bridge these levels where it's either like fairly kind of about hardware and interfaces, or it's something that's kind of like bring up test verification script kind of level. So a lot of times I'll be working in hand with another like firmware development or a system driver development team. So their work will typically be in C or C++, or maybe one of the kind of newer systems development languages. As far as I'm guessing that they were expecting a more autonomous vehicle-like question, and I would say that generally most of the code base for autonomous vehicles will be in something like C++ or kind of one of the more safety-oriented versions of C for the embedded parts.
Which of the 5 areas in ECE, those being nanofabrication, signals and systems, circuits, hardware systems, and software systems, did you focus on at Carnegie Mellon, and why did you choose that specific focus?
Yeah, of those, I probably had, my coursework was probably about a 50-50 split between hardware systems and kind of the software systems. So I think some of this comes through in the TA opportunities, actually. Of all the let's see, maybe like 5 or 6 semesters that I TA'd a course, I think 3 or 4 were for some sort of C programming, and another 2, maybe 3, depending on how you count it, were related to developing, kind of putting together embedded systems, hardware, PCBs, stuff like that.
How was your experience with Apple, and how did it kind of like compare with Google or other big companies? And would you recommend working at one of those companies for other people?
I mean, the short answer is, like the most compact answer to that is if you have the opportunity and it's kind of it's the right thing that lines up with what you're looking for at the time, yes, you definitely, I would definitely recommend working at any of those places. They definitely have kind of different environments. So just kind of the most in the most general terms, and of course they all have many teams, so the experiences could be different. But I think generally Google kind of pushes more towards like literally as much of a single code base as possible, as much shared infrastructure as possible. Sometimes that means there's that some difficult problems can become really much more possible, and at the same time, some things that like seem like they should be fairly easy to put together can end up having like more dependencies than you would expect. I think one of the strongest things that I really enjoyed about Google is that the I think like kind of the way that they review code across teams really sets a standard and really has influenced a lot of the rest of the software development industry. So on the other hand, with the Apple side, I think there's kind of more segmentation. There's which I think is probably not a super surprise. I think there's it's well known that especially the hardware teams within Apple are much more secretive between them. The really cool part about it is that there's just this real focus on making stuff that is really high quality, really a really great experience, and that goes all the way down to like pretty much every engineering discussion, and there's not a lot of policy that you can make for that. It really has to come from the people and the engineers.
Since you had a lot of really cool experiences in high school and college and right now in your current career, do you have any information you'd like to share with our audience or any final thoughts or advice on career and college planning?
General advice. I think probably the most general thing is that especially when it comes to like I know that the viewers will be in like maybe different bands. Maybe they're literally thinking about like what looking at college options right now and trying to figure out like where to go. I think sometimes there's more than one right answer about where to go. Sometimes you just have to pick, and yeah, will probably influence like maybe the things that you work on later. But maybe both of the options are actually like really good, and it might not matter exactly which one you end up picking. There'll probably be really good opportunities in either situation.
All right, so thank you so much for joining us today, Ian. It was really, really nice talking to you. Remember, everybody, to subscribe to our YouTube channel and come back in 2 weeks for our show with Kunal Garg, who works at Wealthfront. And we'd really like to thank our sponsors today, once again, because without them, we wouldn't be here. They really, really help us out so much, and we really appreciate them. Thank you all for joining us today. We hope we could help you out with whatever questions you have about STEM and other stuff. And thank you again, Ian, for joining us today. That's all.
Yeah.
Thank you.
Thanks so much for having me.